Have you ever wanted to go skydiving before? Well, without the invention of the parachute, it would never have been possible. The parachute is a fairly old invention. In fact, the conceptualization of the parachute has been traced as far back as the 9th century. Significant technological developments of parachute design were shown during the pre-Renaissance and Renaissance period. One of the most notable contributors to this invention was Leonardo da Vinci. His contributions would influence all future parachute designs. Ever since the first flying trial in 1595 by Croatian inventor Vrancic, developments in parachute science would improve dramatically and result in the parachute we have today. So, what are the physics principles that parachutes rely on? The main physics principles that are applied to the parachutes are gravity, air resistance, which is also known as drag, and terminal velocity. Firstly, what is air resistance? The air is made up of a concoction of gas molecules, and as you move, they are pushed away. This effect is most apparent when you are moving with speed. If you were to fall out of a plane without a parachute, your dense and compact body falls through the air like a rock in water, and the air is easily pushed around your body. Once there is a parachute, more air resistance is created, and you float down to the ground safely. The large surface area of the parachute is more difficult for the air to travel around, which is why it would feel like the air is pushing upwards on the parachute. It is a form of friction, and it converts some of the kinetic energy of the moving object into other forms of energy, such as heat. This heat then gets dissipated into the environment. We've all heard of gravity and air resistance, but what is terminal velocity? Imagine falling off a tall skyscraper. If we consider the fact that gravity is 9.8 meters per second squared, you would be speeding up by 9.8 meters every second you're falling. Theoretically, if you were falling for about 100 seconds, your velocity would be around 1,000 meters per second. That's even faster than a supersonic jet. In reality, we would never reach this velocity, and it's thanks to terminal velocity. Terminal velocity is the speed where the force of air resistance balances the force of gravity. At this point, there would be no more acceleration, and you would fall at a constant speed, the terminal velocity. So, in summary, a parachute works by lowering your terminal velocity by increasing the air resistance, which acts in opposition of the fall. The results are very dramatic, since they are designed to reduce your terminal velocity by about 90%. The large surface area of the lightweight and flexible parachute fabric causes a greater resistance of air. The fabric of the parachute must be lightweight, yet strong enough to resist tears and be elastic for maximum drag. Modern-day technology and parachutes have really affected society by allowing us to experience activities that we would never be able to experience otherwise, such as skydiving and hang gliding. It opens up new opportunities for those of us who are brave enough to take the drop. Environmentally, parachutes don't have much of an effect, as it is something that does not require non-renewable resources. Although, for some activities, a plane is required to fly up high enough to use a parachute, which isn't so environmentally friendly because of the fuel it requires to operate. Parachute designs differ depending on its application. For better control and speed adjustment, there are tapered elliptical parachutes which provide a variable resistance at different points on the parachute. This design is mainly used by sport parachutists. Rectangular parachutes have been engineered to have dense fabrication of air cells, which results in greater safety. These rectangular parachutes are most commonly used for recreational and training activities. There are several other designs, including square or cruciform shapes used by the Army, which are designed to reduce turbulence and violent swinging during descent. Annular and pull-down type designs are specialized for maneuvering and are used for rescues, and ribbon ring parachutes are used for supersonic speeds. There are several careers relating to the manufacture and use of parachutes. For those who enjoy the thrill and working hands-on, there are paratroopers and skydiving instructors. Paratroopers are specifically trained soldiers that perform parachuting duties in combat situations. and skydiving instructors teach people how to enjoy the sport safely. People who prefer to stay on land would become parachute riggers and parachute manufacturers. Parachute riggers repair, handle, and package parachutes on the ground, and parachute manufacturers produce parachutes for military and civilian customers. To this day, research is still being done to improve the design and use of this technology. In fact, after a failed 100-foot test parachute that became ripped and twisted, a group of researchers and engineers at NASA have been working on building a parachute that is capable of decelerating a Mars-bound craft from superspace speeds. If their parachute design succeeds, NASA will be closer to being able to land a much heavier spacecraft on Mars. This would open up a whole new bunch of possibilities, and is one step closer to having humans colonize Mars. Who knows where parachutes may bring us next?